Hi guys, this is the 2-cell lithium-ion battery from the helicopter that I've been working on, cheap one from charity shop. One of the cells is dead. I'm wondering if I can use the cells out of one of these cheap power banks from Poundland. Cost me £1 each. See if I can stick two together. That's one of the power banks. Tops just clip off them. This is what we've got inside. So these are 18650s, so they're 650 millimeters long. These were 18500s, so 500 millimeters long. So if I do put two together, they will be bigger and heavier than the original. But I was looking at these and they have got the tags on them already, so there's a chance of actually being able to solder wires together or solder the cells together. I have tried soldering cells before and it's not really a good idea to try and solder directly onto the metal casing because you might overheat them. So when I saw these had got the metal tags already welded in place, spot welded or tack welded, whatever you call that, or is it vibration? That doesn't matter. Anyway, whatever. I thought I should be able to use those to connect two of them together. So we will see. Probably not the sort of thing you want to try at home. And I've got an empty metal bin here that if things go wrong and it starts catching fire, I can chuck it in here and get it out of the house. So I'll just pop this one open so you can see what I'm talking about. So there we go, I've got two now. So what I want to be able to do is solder that onto there and then solder the normal connector cable onto there and onto there. So that's all places that have already got solder on them. But we need the balance lead to go down to the bottom so we can do balance charging. I'll probably reuse this lead. So ICR 18650, 1200 milliamp hour, QBOFAH, whatever that means. I've transferred the wires from the faulty battery. So these two batteries I've taken out of the power banks. I used the existing metal tabs to join them together, and I've connected on the balance lead there. The same at this end where there was the existing metal tab. I've used that and the existing soldering tab there. So it's all back without me having to solder directly onto the cells. I didn't pre-charge these, so I don't know what charge they've actually got. So they're a little bit low at the moment, which is good. Well, that's measuring the internal resistances. They look pretty good compared to the old one that was up around 400. I've reset my charger here to do lithium ion.
we go. Okay. Let's see what happens. Well, that says it charged for 63 minutes and it's full now. So I'll plug it into the helicopter and see if it runs. Right, hold it still. Slowing down. Stopped. Okay. Is that because we've drained the battery that quickly? Or is there some sort of override in there that checks for low voltage? 7.8. Come on. 3.9. Yeah, it looks like it might have some sort of voltage protection circuit on the helicopter. Instead of chatting about it, why don't I try my LiPo instead? See if we get the same problem. Right, let's try it with the LiPo instead. Right. Right, well that's still going okay, so the LiPo's giving it enough power. So that means my Poundland lithium ion battery isn't up to the job. It was worth a try. Obviously those two cost me £1, or £2 to be exact, £1 each, which would have been cheaper than buying a proprietary lithium ion battery, but it didn't do any good. Couldn't supply the power required. Just check their internal resistance after we've been playing with them. Still much better than the faulty ones. Well, I'll charge it up again, but it looks like trying to make a cheap battery, lithium-ion battery from a couple of cheap Poundland power banks, is not going to work for me. They're not supplying enough power. Still, it's worth a try. It cost me £2 to do it.